Hi guys, hope you all are doing good. So in this lecture we are going to learn one of the most famous slotting algorithms in computer science. So its name is quick slot. So by the end of this video you will understand what quick slot is, how it works, why it is fast, its algorithm and a complete example. So without any delay, let's begin. So first we're gonna see what is in slotting. Suppose we have some numbers. Suppose the numbers are 5, 2, 8, 1 and 9. So initially these numbers are not arranged in order. If we arrange them as 1, 2, 5, 8 and 9. So this is in ascending order. So this process is called slotting. So slotting means arranging a data in a particular order. So now we're gonna see what is a quick slot. So quick slot is nothing but is a slotting algorithm that follows the divide and conquer technique. So divide means breaking a problem, means breaking a big problem into small problem. Then and conquer means solving these problems, in solving these smaller problems. So the conquer means solving these smaller problems. So quick slot represents the divide the array into smaller parts and then slot them. So why it is actually called a quick slot? So it is called quick slot because in practice it is one of the fastest slotting algorithms. For large amount of data, quick slot performs very efficiently. So now we're gonna see an important term, what is a pivot. So now we're gonna see what is a pivot. So pivot is nothing but it is a special element selected from the array. So the entire slotting process revolves around this pivot. So usually we choose first element or last element or middle element or any random element. It's our wish. For simplicity, we will choose the last element. So let us take an example, an array. So let us take, suppose, let's consider an array that is 4, 7, 2, 9 and 1 and 5. So this is initially not slotted. So we select the last element, suppose last element is 5. So pivot is equal to 5. So now compare every element with 5. So number smaller than 5 goes to the left side and numbers greater than 5 goes to the right side. So smaller than 5 are 4, 2 and 1. So this should be right left side of 5, 4, 2 and 1. So 5 should be right in middle. So the numbers greater than 5 should be written right side. So the numbers are 7 and 9. So 7 and 9. So as you notice something important, that the 5 is in correct position. So this is the magic of quick slot. So now we're going to solve the left slot, means left side of the array, which is left side to the 5. So now the left side elements are 4, 2 and 1. So now choose the last element. We are repeating the same process. So after partition we are choosing 1. So 1 should be right. The numbers which are greater than 1 should be right side. So 2, 4. So now this is also slotted. So now we are going to move for right side. So 7 and 9. So we are going to choose last element. So 9. So the numbers less than 9 should be right left side. So 7. So now pivot reaches the correct position. Now the partition has done. So now we are going to write the final array, that is 1, 2, 4, 5, 7 and 9. So the entire array is slotted. So the quick slot how gonna works is we need to choose a pivot first and place all small elements on the left side and place all large elements on the right side. So repeat the same process on left and right subarrays. So continue until every subarray contains one element. So we are done. The arrays become slotted. So this is the basic analogy of quick slot. So I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So thanks for watching and see you guys in the next lecture.